You've seen this before, right? Exponents have more meaning than they have value. You've seen that before. That was back in section 4.1 when we first looked at exponents. And we're now looking at exponents again, this time for negative exponents. We haven't seen these before, and there's a little setup that needs to be done first, and that is simply to remind you, page 4.6-1, about a reciprocal. And so in example 1, we have some numbers. And we're going to identify its reciprocal. It's probably easiest just to show by example what it is. For example, we have 4/9. Its reciprocal is the inverse fraction, meaning instead of 9 being in the denominator, 9 goes to the numerator, and likewise 4 moves to the denominator. So it's simply a flipping over, if you will, of the fraction. And if the fraction is negative, like negative 5/7, then the reciprocal is also negative. In this case, negative 7/5. If the if the number is a whole number, we could think of it being over 1, and then its reciprocal is 1 over 6 in this case. And D, negative 8, again, the fact that it's negative doesn't matter. The reciprocal will also be negative. In this case, 1/8. And if it's a variable like x, its reciprocal would be 1 over x, or 1 over a if it's a, etc., etc., etc. So that's just kind of an introductory idea about negative exponents. But keep in mind this: exponents have more meaning than they have value. Now I'm going to skip a couple pages in the book. I'm going to move over to page 4, excuse me, where we see this graph. And this graph is pointing out something to us. Now, in the reading, and remember, I'm expecting you to do the reading in the book, whether you do it before or after the video, or both. Probably better to do both. This is in the book, but there's material before that that leads up to it, so be sure you do read that. Let me start over here and remark that 2 to the 5th power, 2 times 2, well, let me write that down. 2 times 2 times 2 times 2 times 2 is 32. 2 to the 5th power is 32. 2 to the 4th power is one less factor of 2. It's only 16. 2 to the 3rd power is 8. 2 squared is 4. 2 to the 1st is 2. And all of these numbers, of course, on the number line are to the right of 1. 2 to the 0 is equal to 1. We've seen this before, too. Now, negative exponents. Look what we're getting into. 2 to the negative 1. It's 1/2. See, what's happening is we're dividing each by 2. You keep dividing by 2. Divide 2 by 2, you get 1. Divide 1 by 2, you get 1/2. Divide 1/2 by 2, we get 1/4. Divide that by 2, we get 1/8, and then 1/16. But look at the exponents. They're decreasing by 1. 5, 4, 3, 2, 1, 0, negative 1, negative 2, negative 3, negative 4. Notice all of these numbers. This is really important here. Notice all of these numbers in this area right here are positive numbers. Let's just sink that in. Let that sink in for a moment. Positive numbers. Positive numbers. Am I sure? I'm positive. So are they. Here's 0. Where would the negative numbers be if we had them on the number line? They'd be to the left of 0 over here. But they're not. These are positive numbers. They're small numbers. They're less than 1, but they're positive numbers. Now, why am I emphasizing this so much? Look at the exponent. The exponent is negative. Negative, negative, negative. What this indicates is the following. A negative exponent indicates a small number, but not a negative number. When we see 2 to the negative 4, we're not talking about a negative number. We're talking about a small positive number. A small positive number. Numbers less than 1, typically, they don't have to be actually, but typically is what this means, but greater than 0, which means positive. These are positive numbers. So, if you need to come back to this idea and say, wait a minute, that should be a negative number. No, with a negative exponent, they're positive numbers, but they're small. So when I write up here that exponents have more meaning than they have value, the meaning of the negative in the exponent, it actually means reciprocal. Remember how we were talking just a little bit ago, probably 2-3 minutes ago, about reciprocals. What's the reciprocal of 2? The reciprocal of 2, thinking of a 2 over 1, is 1/2. So if I were to continue this and I said, here's a number, and here's its reciprocal, if the number were 2, the reciprocal would be 1/2. If the number were 4, the reciprocal would be 1/4. If it were 8, the reciprocal would be 1/8. You see the connection? 1/2. Reciprocal of 2. 1/4 is the reciprocal of 4. And 1/8 is the reciprocal of 8. And on and on and on. So there's a definite connection here with this negative exponent and reciprocal. In fact, that's what the exponent means. When I say that the exponents have more meaning than they have value, that negative doesn't give us a negative number, does it? No, because it's a small number, typically, less than 1, typically, but positive. So that negative means reciprocal. That's what the negative exponent means. Okay, so let's see how that is played out in this next slide here. We have this rule. X to the negative n equals 1 over x to the n. Now that can mean all kinds of things. And we can see so in example 2 on page 4. So this is page 4.6-4, example 2. And it asks us to consider, first of all, 4 to the negative 3 power. 4 to the negative 3. According to this rule here, something to a negative power means 1 over. Now we saw that before. 1 over, that meant reciprocal, right? There was a couple ways that we could see reciprocal, but this was one of them. Is 1 over x to the n. Will that be a negative number? Remember the number line. This is a small positive number, but not a negative number. In fact, according to this rule, and according to understanding, that is 1 over 4 to the 3rd power. Now, that's a pretty small number. 4 to the 3rd, 4 times 4 times 4, is 64. So 1 over 4 to the 3rd becomes 1 over 64, which on a ruler would be a very small measurement. It's hardly anything at all. Hardly anything. But it's still, it's something. But the point is, it's a small number. Why is it small? Because of the meaning of the negative in the exponent. It means reciprocal of, and it means 1 over 4 to the 3rd, 4 to the positive 3. Okay? Let's see. What other examples do we have here? Example B says 5 to the negative 2. That's 1 over 5 squared. And 7 to the negative 1 is 1 over 7 to the 1. And letter D here, x to the negative 1 is 1 over x to the 1. Typically, we don't write x to the 1, we simply say 1 over x. Or in this case, 1 over 7. Now, 1 over 5 squared, that's 1 over 25. We can evaluate that. So usually we don't leave the 1 in the exponent. We would simplify it to have no exponent in that case, or at least no visible exponent. Still got an exponent of 1, we just don't need to see it. Okay? All right. Next. Excuse me just a moment. Okay, good. My whole slide didn't show up. I wanted to make sure it was all there. You probably saw it from the beginning. But anyway, notice how this idea that the negative means reciprocal shows up when we actually have a fraction. Remember, the reciprocal of a fraction means we invert the fraction. So notice that it becomes b over a. But in the process of inverting the fraction b over a, the exponent goes from negative n to positive n. Why is that? Well, let's take an example, numerical example, simple, like 2/3 to the negative 2 power. This is 3/2 to the positive 2 power, which is 3 squared over 2 squared, which is 9 over 4. Or we could think of it as 3/2 times 3/2, which is 9/4. Think, though, about the reciprocal of 9/4. What would that be? I'll do a different color because it's a different problem now. 4/9. Where would that come from? Can you think about it? 2/3 times 2/3. Do you agree with that? Think about it. 4/9. Yeah. You agree that's 2/3 squared? Do you agree? 2/3 times 2/3 is 2/3 squared? Okay, well here's what I'd like to point out to you. These two numbers, 9/4 and 4/9, are reciprocals. Which means that these two here must be reciprocals also. Well, I see 2/3 and 2/3, don't you? Yeah, well where's the reciprocal part? Yeah, that's right. The reciprocal part is found right in that symbol right there. Because, say it with me, exponents have, no, say, everyone, come on. Okay, exponents have more meaning than they have value. Good. Everybody in the back row. Exponents have more meaning than they have value. Okay, all the men. Exponents have more meaning than they have value. Good. All the women. Very good. Okay. So this suggests the meaning of the negative in the exponent. The meaning is reciprocal. So we see reciprocals here, and the only way that they could be reciprocals is from that negative symbol. Okay, well, there's more explanation of that in the textbook, and I hope I didn't confuse you by this little bit. But I'm going to have to erase everything here and start fresh with example 3 on page 4.6-6. Example 3. So 3a, we have 5/9 to the negative 2 power. According to this rule, we're actually going to make two changes so this is the same value, and they are indeed equal. We invert the fraction, and that's the first change. And the second change is we change the exponent from negative to positive. In other words, we're taking that negative, leaving the n alone, really, making that negative into reciprocal of. And that's how that works around. So this will become 9/5, that's the one change, to the positive 2 power, the other change. Of course, in this we could say that's 9 squared over 5 squared, and that's 81 over 25. Okay? Let's see, part B. 4/3 to the negative 3 power. Same idea. Two changes, actually. We'll invert the fraction and make the exponent positive. So it becomes 3 to the third over 4 to the third. That happens to be 27. You can multiply it out to demonstrate that. Over 64. And part C, 6/5 to the negative 1 is 5/6 to the positive 1. And remember what I said about, the positive 1 exponent, it doesn't need to be shown. So just 5/6. And let's see. X over 2 to the negative 5. Which would become 2 over x to the positive 5. And that's 2 to the 5th over x to the 5th. It's 32. We saw that number earlier. Over x to the 5th. Okay? So that's how we can work with fractions and negative exponents. Okay. Lastly, exponents, positive and negative, have those rules that we've seen in the past. We saw it in section 4.1. We saw rules, the product rule for positive exponents. That's when we multiply and the bases are the same, we simply add the exponents. You might remember that rule. Quotient rule, we use this to subtract exponents. A minus b. Power rule, x to the a to the b, we actually multiply the exponents. And of course, here's the new rule that we're working with now. X to the negative n equals 1 over x to the n. But negative exponents work within the product rule, the quotient rule, and the power rule, just like they would as positive exponents. So for example, looking at page 4.6-8, example 4, these might be in different locations. So the first one I see is part A, x to the 7th times x to the negative 3. Using the product rule, and we use product because of the multiplication here, we get x to the 7 plus negative 3. And that becomes x to the 4th. And we're done. Voila! X to the 4th. Consider B, which is similar, but it's w to the negative 2 times w to the negative 5. When we combine these and add them together, we get w to the negative 7. The thing about this is correct, w to the negative 7, but it's typical for us to write final answers, not always. I'm certainly asking you in these exercises here. But to conclude any problem with exponents in section 4.6 with a positive exponent only. That means that we have one more step to do here. And that is to use this rule here and rewrite it as, can you guess? That's right, 1 over w to the 7. Oh, by the way, I have a question. Should this be a negative number? It's negative exponent, right? Negative number? No, not at all. We saw in the beginning how these negative exponents typically mean small number, but don't mean negative, the small positive number. So, no, this should not be negative. This is fine just as it is. It's correct. Okay? Part C here is using the quotient rule. Part C says we have c to the 3rd over c to the negative 4. Wow. Now this is going to be a little bit tricky. You're not going to like this so much, I don't think. It's only because it's not what we'd like to have it be. But we have to follow the rule. And the rule for a quotient is that we subtract top exponent minus bottom exponent when the bases are the same, and they are. They're both c's here. But we subtract the exponents. Watch this. Don't skip steps. Watch this. C to the 3 minus, like I'm supposed to, it's subtraction, right? Minus what, though? Minus negative 4. This is where we need to be careful. This becomes c to the 3 plus positive 4. In other words, c to the 7. And it ends up being a positive exponent. And so we're done. But notice this especially. The minus a negative became plus a positive. Okay? Let's see. Part D of this example says we have x to the negative 3 over x to the negative 1, which is x to the negative 3 minus negative 1. Again, quotient rule, right? Quotient rule means we subtract top exponent minus bottom exponent. That's exactly what I did. Top exponent minus bottom exponent. But don't skip steps here because it will definitely make things confusing. That's x to the negative 3 plus 1, or plus positive 1. That's x to the negative 2. We're not done, though, with this problem because it has a negative exponent. We have one more step, and that's, again, to use the rule that we see at the top and make it 1 over x squared. Okay. Here's letter E. It says a to the negative 2 to the negative 3. Parentheses. A to the negative 2 raised to the negative 3. We only have the one base, and that's a. It's a to a power, then raised to a power again. Well, this is the power rule. And when we have something to a power to another power, the powers multiply together. And there's an explanation in the book, especially in section 4.1 about that. So if you are confused about this, you might want to, why is that? Well, go back and read section 4.1 on the power rule if need be. But we're just going to apply the power rule here and make it a to the negative 2 times negative 3. And because they're both negative, when they multiply, that becomes a positive 6, or a to the 6th. And so that one is complete. Letter F, p to the negative 5 squared. That is, again, the power rule, p to the negative 5 times 2. That's p to the negative 10. But because the end result so far has a negative exponent, we really need to do one more step and make it 1 over p to the 10th. All right? I think that's all I have for you today. Well, at least in this section 4.6, it is. So please, again, read the book. Get as much as you can out of it. If you have questions, send an email or discussion board message, and hopefully that'll be answered ASAP, as soon as possible. There you go.